Hello and welcome to another video in the cybersecurity lecture video series. And today it's going to be an interesting session because it is end of theory. We'll be discussing little bit of theory and more of hands-on session. So the topic under discussion today is SQL injection. So normally whenever you use a website or any application for that matter, however you interact with the system, there is always these forms that you come up with, right? You are asked to register on a particular website or you're asked to give some input, feedback or whatever it is. The way to interact with the backend of any application is through these forms. So in this example, let's consider this login form. Now what is it doing? I'm saying that SQL injection can happen through this form. But how does it happen? Because this is an interface between the backend services of a web application and the database. So now don't think like a software developer or a software engineer, think like a hacker. Now hacker, what does he want to do? He wants to tamper with your backend services or a database for that matter. But how does he get into your system? These are the inputs that he can find, right? These are the input fields. So whenever you fill something and click on login button, what happens? It is going to send a post request to your backend service along with the information that is in this form that is filled by you, and it is going to either store that data on a database or it is going to check for some information. But essentially these are the input fields from where some suspicious code can also get into. So that is the essence of SQL injection here. So how do the hacker or how do the attackers inject something very malicious here so that it impacts your database? That we'll understand step by step in the further slides. So in essence, SQL injection means injecting SQL query via input fields. As I told you, this form is the only interface through which an attacker can send some kind of malicious content which impacts your database or a backend service. Now in case the form or the backend service is vulnerable, it is not checking the data, then what happens? Whatever the attacker is entering is directly going to get into your database and backend service, and it is going to change there. Whatever he wants to do, he is able to launch an attack there. So what happens here? Data stored on a database can be exposed, it can be modified, or it can be deleted. Normally, when we talk about any operations that have to be done on a database, that is the CRUD operations, it has to happen only through your backend services. But in case there are any loopholes in your backend services, what happens is the attacker can easily manipulate the data in the database using that. So the major problem here is input data not getting validated. So that is how an attacker is going to perform an SQL injection attack. It is through this very simple forms that he can launch a SQL attack. Now coming to the backend part, we said that the form is going to act as an interface where you put some kind of information and it goes to your backend. Now normally when you click on login, it calls a service. Now assume that we are calling this service here, and what is the service here? It is called records, and here we are receiving the data through the request body. And what are we doing? We are reading the data in this variable called data, and then what are we doing? We are building a query here using what? Data.id. So mind you, what is exactly happening here in this part of the code is that you're not checking what kind of data is getting in. So you're blindly giving it to this query builder. So you're concatenating whatever information you get from the request body and putting it in the query, and this query is getting called, and this query is making a call to your database. So it may be any input for that matter. It doesn't have to be just username. So I can type anything, special characters, everything is going to go get concatenated with this string, and then it is going to make a call to your database. So now what happens? Let's say you are an innocent person, you don't know how to launch an attack. What will you do? You normally type your username and a password, but attacker is not going to think like that. What will he do? He will try these sample commands. And what are the sample commands here? Select star from users where ID equal to 101 or 1 equal to 1. That means he is making this query true. And how is he doing that? So besides typing 101 here in the user ID space, he is also typing 1 equal to 1. Why is he doing that? Because he wants this condition to be set true. so that he can either log into the website or he can actually expose whatever information is stored on the database. So you take a keen look at these commands on how, by concatenating some extra information, an attacker can either drop a database entirely, or he can bypass a security check, or he can do some other criteria based search. So go through these three statements very keenly. Here he is bypassing the true condition by using or 1 equal to 1, and in the second statement he is doing a drop of a main DB, and these are the comments that are used in SQL syntax. And in the third statement he is searching for records which have the date of birth or date as so and so, and he is commenting the extra line of information here, and that is all happening merely through the forms. So now we understood how SQL injection attack can be performed. Just to reiterate, so it is all happening from this form, and what is allowing it to happen is this piece of code and specifically this query. So make a note of this query while we discuss the hands-on exercise. It's going to help you. So these are how the attackers can launch the attack on a database. He can expose the data, he can bypass the authentication step, or he can expose any other information. And then how do we prevent it from happening? We understood that the attack is happening through the form input fields, and the problem is not having a proper validation before building any query. But how do we prevent it? That is the crucial step. So here it needs a proper data validation. Now this validation has to happen on both the sides, the client side as well as the server side. So when we talk about validation on the client side, you can set certain patterns, regex patterns, saying that your input field can take only certain values. So it should not allow any special characters. It can be only lowercase and uppercase letters or numerical values. So you take only alphanumeric strings as input, but you don't allow any other special characters to be there in the username. So that's how the client side and the server side validation are going to help you in validating the input before building any query. So that is like stopping the attack even before a query is built and sent to your database. So when you have a proper validation in space, your database is safe. And further to the client side and server side validation, you can also have type checking of input data. So let's say I am validating user ID. So as we decided, it's going to have only alphanumeric data. So if there are any other values or any other data types which are coming in, then you directly reject them even before building the query. And also sometimes what happens is, you are very well aware about the security checks that have to be performed. But what if unknowingly you downloaded an package along with your application? In order to run your application, you are depending on a third party, another tool or a library. If that has any kind of vulnerabilities, even that is going to impact your entire database. Meaning, let's say you are building application A in Python and you are using libraries ABC, and these are all the libraries that you've developed, or they are coming from a trusted source. But let's say there is another application by name X. Now it is coming from an untrusted source, but you found it online. Okay, this is going to serve my purpose, so you're using it. But what if it has vulnerabilities? Even that will be impacting your service, because you are using that package and packaging your service entirely using that. So it is always good to avoid untrusted packages in developing any application. And last, you have to enforce security coding practices in teams. So any web application development team or application development team should be aware of certain standards. So they are aware that, okay, these are the basic steps I have to follow in order to launch my application and push it to production. Unless these are met, your development team should not be pushing any code to the production environment. So by enforcing all these steps, we can ensure that SQL injection can be prevented thoroughly. Now moving on, we have the hands-on exercise. As I told you, this series is not just going to be theory. You have to understand the theory and apply it in the practice as well. So we will be using OWASP Juice Shop, and this is the challenge you are expected to solve with the knowledge that you gain from this video. So before we get there, I would like to summarize it further again for you. So the SQL injection is made possible through the forms which don't validate the input in the first place. they don't validate input on the client side, or they don't validate the input on the server side, if there is no proper validation, if there is no proper check, and the queries of this kind will actually cause your database to go down if there is any attacker out there who is actively trying to launch the attacks. And these are the type of statements. And these are the type of statements that he is going to put in the input forms and see. So this can be 101 or 1 equal to 1. He'll inject it here and see whether it's working or no. So these are the prevention steps that we learned. So make a note of this as well as this, so that you know in the exercise how to launch an attack and also how to prevent the attack. So this is a login admin challenge. So what is expected in this challenge? There is a login form which has vulnerability, and this is a deliberately put vulnerability so that you understand and experiment with this website. And then the user input is not sanitized, in the sense it is not validated on the backend or it's not validated on the front end. Then the queries are exposed in the console. Now we will see that during the practice session. I'll open the website and show you where exactly it is getting exposed. And using this, using all these vulnerabilities, because these are the weaknesses in your website, what is the attacker going to do? Inject an SQL query, and there he is bypassing the admin login altogether, though he doesn't have the admin login credentials in the first place. So this is a screenshot I have taken, and this is the login page, where here, for example, I inserted a single quote and a random password because I don't know. So I am playing a guessing game here. At the same time, I am checking whether your application is able to handle this single quote or is it not handling, because I am doing a trial and error check here. And now you are supposed to think as an attacker. So you entered this. Now what is happening? It's giving me some random error. So what I do? I go and check the network logs. What do I see here? The complete SQL statement that is getting used in the backend is exposed here. This is extremely bad coding style, because what is happening in the backend, the front end, the client should never know, or the front end users should never get to know what is happening in the backend. But here what is happening? On the contrary, the entire SQL statement or how the authentication is happening, you are exposing that statement. So with this information, what will a hacker do? Okay, now I understood that in the backend, this is how he is doing a login check. So what will he do? He is going to bypass this. So how do you bypass this? You have to solve the challenge. So this is the website I showed you in the slide before. Here, this is the extremely bad coding style that we discussed. Now let's see it in practice. So this is the website. Now I'm going to think like a hacker. What am I doing here? I'm entering a single code and then I'm just typing something at random and clicking on login. So it says I solved a challenge. Similarly, you will also be able to solve a challenge. So actually, in a real-time ideal scenario, this kind of input should never be taken. But what is happening? It is even allowing me to click on login. Now let's check the inspect logs. Moving to the network logs, what do I find here? First, let me clear this and I will make the submission again. So here you see there is a login request going in. And what is the response I am receiving here? Is the complete SQL query that is being used in the backend in order to authenticate a user. So basically, I know what is happening in the backend now. When I know what is happening in the backend, I will also try to make sure that whatever I do here, I will be able to bypass it somehow. Because I have knowledge about what is happening behind the scenes, I will try to come up with a scenario where I can bypass it. So how will I do that? Now let's say it's saying email equal to so and so. So basically, I will try to make sure that this statement becomes true so that I bypass the login. What can I do for that? Select users where email equal to this. Right now it is failing because the syntax is wrong and several other reasons and the condition is not being met. So I will simply do this, or true. Now will it allow me? Let's check. This is the request which went in. So right now I am able to change this, where email equal to a blank and then or true. Now I am just 2 characters away from solving this challenge, but I don't want to reveal the answer here, based on the knowledge that was shared in the slides with you, where I asked you to keenly look at the syntax of the commands that an attacker can use directly, using the knowledge of those commands, you will be able to solve this challenge. So this is partially correct but not entirely correct. If this is entirely correct, then you will be able to log in as an admin directly. So do solve this challenge and update it on the leaderboard, and let's discuss the solution in the next session. So keep in mind that this is a bad coding style and you're supposed to bypass the admin login using the knowledge that you've gained in this session. So that's it for today's session.